Hi, welcome to this short video where I'm going to detail what's new in the GLOBEClaritas release 2023.1.1, which came out at the beginning of January 2023. So the first thing I'm going to demonstrate is some new improved functionality in the Condor application. So if we go to the Geometry tab, click on the Seismic Header Cross Plot button and then select GNS Job 2 HDF5 and let the data load into the Condor application. So now you can see that the data is loaded and we've got a display of an RMS amplitude map from the seismic trace header. So with Condor we can zoom in and out just by using the middle scroll wheel. And so what I'll do is demonstrate the new functionality that we've added in. So if you see there's a drop down menu that says flag. So we can read trace kills from the HDF5 trace type header, we can save trace kills into them, or we can convert the trace type header into a flag header rather than just setting the trace as live or dead. We can restore the original TR type values from before we started picking, clear all flags we've applied, flag all traces, flag low high value cells, or enable kill flag test mode. And then if I right mouse button in here, I've got click to select traces to kill. So i.e. set the TR type to equal 2. I can also, rather than setting it as flag kills, I can make it so that it populates a new trace header called Condor flag 1 with a value of 1 for a trace that's been selected, or 0 for unselected traces. So if we leave it at that and say click select individual traces, I can go up to a trace up here, click, and it'll put a trace edit in. So I can click individual bad traces, I can kill bad shots by selecting rows shot IDs, or I can kill bad channels by selecting the column. I can regain automatically based on the kills that I've applied. I can also unselect the flag traces if I want to, and then if I go back up to the flags menu, I can enable kill flag test mode. And you see as I hover across the color bar, any traces that have amplitude ranges within the sort of to the right hand side of the color bar will be selected and killed effectively. So I can sort of automate some of the trace editing if I wanted to. So this basically mimics the behaviors in the aerial application, just in a more user-friendly, nicer looking application. So I would encourage you to try that out and have a play around with Condor and see how that works. And then when you come and exit this, we can save and exit the data, or just quit and discard any picks that we've made, and it'll update the trace header flags. So what I'll move on to next to discuss in this release is the new automated velocity picking application, which is called Raptor. So Raptor basically takes in a seismic data set, a pre-stack CDP ordered seismic data set, and calculates a high density velocity field picked on every CDP, densely down the trace as well, velocity model. And so effectively what it's doing, it's analysing coherency across the gather, so where the gather's flat based on the velocity that's being scanned, and gives you optimal flatness of gather and coherency in terms of stack response, then it selects that as the optimal velocity. It's ideal for post-imaging velocity analysis, so pre-stack, post-imaging sort of time domain work. And what you do is load a data set in. I will select, in this instance, the GNS Job 3. And you see you get a map interface, so obviously for a 2D line it's just a single line shown. For a 3D volume it will show a cube. For a land data set then the geometry will be displayed effectively on there. And then you can play around, so we can define, if it was a 3D data set, the inline cross-arm range we wanted to process. We can set a min-max RMS velocity and the step between down that velocity we want to go. We can set a maximum interval velocity that we expect to see in this data set. And then in terms of the resolution of the picking, we can define how many layers we want to look at. So it defaults to 50 layers on a CDP, so it's fairly dense. The window length can be defined in milliseconds, and then the step in samples between each correlation window is also defined. And then we also have two depth-dependent smoothing parameters in terms of the radius of the smoother and the amount of smoothing we apply. So once we're happy with those parameters, we click on the Start button, and it will ask us for a dataset name. We give it a dataset name, which is a SegY Revision 1 velocity field, and then we can click on the Velocities tab, and it will start to build the velocity model. We can choose to display it in layer if we're looking at 3D, so we can look at effectively time slices through the velocity model. Inlines, which for a 2D line is the optimal way of displaying it, or in 3D dataset we can look at inlines or cross lines through the data. And you can see the velocity model building up as it goes along. You can see at the moment that the velocity model is quite noisy because the depth-dependent smoothing is applied as the last stage in the process at the end of Raptor's work. So if we leave it running, see what sort of model it produces. Right, now you can see that the velocity model has been completed and the depth-dependent smoothing has been applied. So we've got a nice smooth velocity model that hopefully looks geologically realistic. However, if you decide that you didn't like the work or you thought you could improve it, what you can do is click on the clear button to remove the existing model. That will then open up the parameters so you can adjust the velocity ranges and the resolution that you're applying, and then you can click rerun to run it again. Or if you think just that it's been over smoothed or not smoothed enough, you can alter the depth-dependent smoothing parameters and just rerun the smoothing part of the process. So basically once that's run, you've now got a new velocity model that you can stack the data up with. So if I close the application down and then go to Seismic Data tab, use Seismic, and select to display data with human picked velocity field compared against a velocity model out of Raptor. So that's a human picked velocity model. Doesn't look too bad, quite a reasonable looking stack. And then that's our Raptor based one. So what we can see is we're getting a little bit more coherency and continuity on this rollover event up here. Similarly on these events here, we've got more coherency and strength in the events. Again, this event here, it fades out a little bit on the human picked velocities, is more consistent and stronger across the data. This rollover event or on lap onto the Taranaki fault here is improved in the Raptor velocity model. Similarly, these events down here are a lot more coherent and stronger after Raptor than they are with the human picked velocities. And again, we can probably look around up in the shallower section as well and see improvement in terms of the water bottom itself and in the events below the water bottom as well. So that's Raptor. I'd encourage you to give the application a try and see how you get on. What I'll talk about next is the FWI-RTM application. So whilst this was released as a separate standalone application that could be run from the command line, in an intermediate point between the 7.4 release and the 2023 release, it's now available to be launched from the Claritas launcher using the FWI-RTM button. It's got a separate install, so you do need to install it separately, and it is licensed separately because it is technology that we've acquired rather than developed. So there's a need for us to cover the costs of that purchase. But if we click on the FWRTM button, it brings up the application, and we can either open a brand new parameter form for the job, or we can open an existing job from the area where it's saved it. So if I click on that one, it opens a TRV434RTM job. And so what we read, our input data is SegY Revision 1 files, and that's one for the velocity model, a depth variant velocity model in SegY, and similarly one for the input seismic shot records. The documentation details which headers need to be set up and how they need to be populated, so it's all there in the documentation to make life easy for you to set the data up and make sure everything works as you expect it to. There's some tools in here for confirming that the data looks good. So there's one that allows us to QC the survey, so both the seismic data and the velocity model, and make sure that they're sitting where we expect them to sit. We can check the earth model, so we can review the velocity model that's in there and check that looks okay. Similarly, we can check the shot gathers and QC those and make sure they look okay. And we can also look at trace header information as well. So we can review the trace header information that we're looking at in here. So here we can see the trace header information for the velocity model and a little interval velocity display of that location's velocities. If we're happy with it, then we can go ahead and effectively run the RTM or full waveform inversion or forward modeling process that we've got. So basically we click on the run button and it launches the application. So the application can run either on GPU or CPU. If you leave it with GPU if available, then it'll basically interrogate your system where you're trying to run the application when it understands what's available. So if it identifies suitable GPUs, which need to be NVIDIA GPU cards because of the CUDA development libraries that are used by this application, then it will run on a GPU. Otherwise it will revert to running on a CPU basis. As you can see, there's an awful lot of controls in here for the application in terms of tuning and working on your data and what sort of velocity, what sort of frequency range you want to migrate to, etc. So plenty to play around with. I'll close that down and I'll show you some results from this process. Right, so so in this PowerPoint I've got basic screen grabs of the data through so we've got the Kirchhoff pre-SDM result, which looks reasonable, and then we've got the RTM result. So I think what we can see there is that we can certainly get better imaging of the on-lapping onto the Taranaki fault, which sits around about here. So the coherency of the events is better, and it's quite a nice imaging result. Apologies for the fact that the data's jumping around a little bit, but I think you can see the gist of what the RTM is doing. So quite a good result, and we'd encourage users to take an evaluation license of the RTM FWI. So one other thing I will show you is, so if we run the application, it basically brings up an interface like this. So it's showing the data set and the estimated primary arrivals and then the estimated multiple arrivals. And then from this it basically saves those as new data headers in the data set. It also creates a delay header, which is effectively the difference between the two headers, and from that we can do some header maths basically to calculate the approximate tow depth for each channel along the gather, and then we can put that approximate tow depth that we calculated into the Octave deghosting application and run a variable tow depth solution for the deghosting, which does seem to give a slightly better result, particularly on these high resolution or ultra high resolution data sets where sometimes they're towing quite shallow and the control of the cable depths is challenging, especially with wave height affecting it, such that whilst you might be towing at a nominal half a meter tow depth, because of the wave height and other things, you're getting quite a lot of variation, and because it's a shallow tow, even small variations are quite significant in the depth difference. So this approach to calculating the tow depths and using that for the deghosting does seem to show some value and benefit. So again, we'd recommend you trying that out. So you can access that by basically going into the Python lib high-res QC directory of GNS Home on your install and launching the high-res QC.py application by using Python 3 application name and then the input data set and the header you want to read. And the header you're reading is the header that contains information on the water bottom picked across the entire gather, which is used by this application. So this is a first stage for us in terms of creating a new dedicated ultra high resolution deghosting solution. So this is our first step on the way to that. It does give us an improvement with Octave, and we're hoping this and what Mark's working on at the moment will give us a significant improvement and a really strong, stable solution for ultra high res marine seismic data sets. I'll leave that running at the moment, and I will also talk about some of the other new functionality we had in this release, but very much around just a brief overview of it. So the key things to look at would be some further improvements to the near surface statics applications, so Tomo 3D, ResStat 2D and ResStat 3D. So with the new AI FBQC application creating new first break pick headers for the tensor factorization AI approach and the neural network AI update approach, we've added the capability into these applications for the user to select which of the trace headers it wants to read in. So assuming you've run the AI FBQC and you've decided that the neural network approach is the best, is an improvement over the first break time header that's been developed by using the auto pickers or the manual pickers in SV, you can select that one and input those first break picks into the whatever static solution you're using, and hopefully you'll get a more optimal statics result out of the application. The FBQC application itself has also been updated, so it now has the option, you can flick it on to run on a GPU instead of CPU. So if you do have a GPU card available on your machine, you can select that option and it should run more effectively and efficiently. And then we've added support for Segwar Revision 2 files as well. So we encountered our first set of Segwar Revision 2 data sets, so we've added some functionality into the software to be able to deal with those Revision 2 format files. And that pretty much sums up where we are on the 2023.1 release. We are already starting development on the 2023.2 release, which includes the work on the ultra high resolution deghosting solution, which Mark is working on at the moment, and we're investigating UI improvements for visualization either of velocity models and fields or possibly seismic data sets for the next release. Thank you for your time. Any questions, please contact support@globeclaritas.com, and goodbye.